Hello coders, welcome to episode 99 of the How to Code Well podcast. Oh my word, 99, that's incredible, wow. Today we're going to be talking about algorithms and where to put them. The title is, Where Should My Algorithm Go? And yes, I see the stream has just changed, flipped over, good. So you can see me, brilliant. Okay, so where should my algorithm go? That is what we're going to be talking about today. In particular, where should it go in an MVC architecture? Now, this was a suggestion that I had from Discord, which is such a good topic, So thank you for suggesting that. You know who you are. And if you've got any other suggestions, I should say, before we start this, for future topics, please do let me know. Put them in the suggestions channel on our Discord server, howtocodewell.net/Discord to join. Okay, so where should my algorithm go? Where should it go in our MVC? I suppose what I should do is break this down into probably 3, maybe 4 sections, this talk. First of all, I suppose we should talk about MVC. You know, I've given a talk about MVC before, so I'll probably go a little bit brief on that one. And then we'll talk about an algorithm. What is an algorithm? Then I will talk about where to put that in the MVC architecture. I've also created a kind of an example of an algorithm and how an algorithm can grow. That we'll discuss, and also the various types of design patterns that you can use to choose your algorithm. Okay, so there's quite a lot to go through today. I hope everybody's well. This is live, as it is every Thursday, here on YouTube at 8 o'clock. So if you've got any questions, any thoughts, then let me know in the comment section. If you've got any questions, then I'll pick them up as we go. Wow, okay. Cheers, everyone, by the way. I'm drinking beer tonight. Woo! I am on Doom Bar. It is a lovely ale, one of my favorites, I think. Very, very nice. So, where should my algorithm go? Let's talk about the MVC architecture first. So M is the model, V is the view, C is the controller. Let's split those up. So the view is the thing that cares about the representation of the data. So it is the thing that you see when you refresh the page. It is the HTML markup. It receives data and then spits that out. It also is the thing that creates the JSON response from an API request. It is fairly dummy in the sense that all it does is it receives data and then outputs that data. It doesn't care about the data itself. It cares about how it looks on the page or how it's represented in an API response. So, bear that in mind. The view shouldn't have any kind of influence on the data. Okay, it should only care about how the data is how it looks on the page or in the API. Or, you get the gist. Okay, the controller is the router. It is the thing that goes, okay, so the user has made this request. It's got this query string in it or whatever. And we're going to map that to a particular routine, and that routine will end up with a response that the view can handle. So the controller is like a switchboard, essentially, that just says this request goes to this controller, and this controller has this view. Okay. So then we get to the model. This is the big boy. This is the beast of your system. It is the biggest part of your application. This cares about the data. It cares about the integrity of the data, how the data hangs together, the validation of the data. It cares about I've said the integrity. It cares about the data. It is data centric. It also looks after things like sessions or wherever the data is stored. If it's in a database, it communicates with that. It's quite a massive beast. So it also handles form submissions, so validates the forms to then turns your inputs into a record in the database. That's what it does. Or it validates that this user can do this particular thing. And it also produces the data and hands that off to the controller, which then hands that off to the view, right? Now, a quick point on this. This is a little sidetrack, but a quick point on this. Your view shouldn't be, if it's an API response, it shouldn't return the field names that are in the database. So your view should have its own representation of what that data is, right? Anyway, that's a bit of a side thing. Okay, so that's the MVC. So model is the data. View is the representation of that data, how it looks, the CSS, all of that fancy jazz. And then the controller is the router. It is the thing that routes your request to that response. Let's just put that on a shelf for now. We'll take that off the shelf in a minute and we'll get back to it. Let's talk about an algorithm, because this, where should my algorithm go? Let's define what an algorithm is. So an algorithm is a series of instructions. These instructions perform specific tasks, they perform a series of tasks to get to a required end goal, let's say. Now, I guess I like my analogies, right? So let's talk about recipes. So you're cooking dinner. Like tonight I had a lovely dinner. My wife cooked me a lovely steak, but we won't. That's a little bit too complicated. Let's talk about making toast. This is kind of what I do. This is my culinary skills here. Let's talk about making toast, right? So in order to make toast, or I could also talk about making a cup of tea, I suppose, but let's talk about toast. So making toast, what you would do first of all is you would get the bread, and then after you get the bread, you would put the bread in the toaster, and then you would press the toaster down thing, the button to press it down, so then wait for it to pop up again. And then you would take the toast out of the toaster, put it on a plate. Then you would get some butter, and then you would spread the butter on the toast. And then perhaps, if you're fancy, you would use peanut butter and maybe some jam or some whatever spread you've got. Then once that's done, you would then cut your toast in half. Now that sounds very obvious, right? But what you wouldn't do is you wouldn't do this in reverse, or you wouldn't mix up the steps. So you wouldn't butter the bread and then put the bread in the toaster. You wouldn't do that. So it is that is an algorithm. An algorithm is a series of steps to produce a particular end goal. In this case, the goal is to create some toast. Or we could discuss making a cup of tea. My culinary skills are about that limit. Okay, so an algorithm has some characteristics. So one of the characteristics is an input. So an algorithm must have an input. Another characteristic is an output, because when you're making toast, the input is the bread, right? So that when you first start this journey of making your lovely piece of toast, the first thing you do is you get the toast out of the bag of bread, right? So you get your bread out of the bag of bread. And then the output of that is you putting that, you put that into the toaster, and then the output would be the toaster popping up, and then that becomes nice, warm, toasted bread. That would become your output for that particular step. The next step would be to butter that piece of bread, that toast. So the input would be the toast from the previous step, which would be the step of the toaster popping up. That would become that that input, and then the output would be the toasted bread but with butter on. Do you see what I mean? It's a small. If you break it up into separate steps, the input of the previous step, the output of the previous step becomes the input of the new step, and so on and so on, and you see where I'm going with this, until you get to the very last step, and that becomes your overall output. Now, the next one is precision. So again, we're talking about the characteristics of an algorithm. Precision. So this is that you cannot perform these steps in any other order. It has to be done in this particular order. Otherwise, it's just not going to work. So you have to do this step, and then you need to do that step, and then you need to do that step. Or you could look at it like this. A step requires, step B requires step A for it to be performed. And then you've got feasibility. So feasibility, how feasible is it going to be for that step to be completed? And then, of course, you've got flexibility. You've got a whole bunch of other abilities. Flexibilities, how easy is it to change that particular step without it affecting other things? Anyway, we can go through all this, like I can dive into this, but trying to bring it back to the point of where should I put this algorithm? Okay, so we've discussed what an algorithm is. We've discussed what MVC is. I would imagine some people have an idea as to where to put algorithms, but I suppose it would be a good idea now to talk about an example of an algorithm in software. Let me just have a sip of my beer for a second. I've still got that annoying cough. Okay, so let's talk about a shopping cart, because this is kind of a very common. We've all purchased things online. A lot of us have actually created shopping carts, e-com stuff. I certainly have. Let's talk about a series of algorithms, or no, let's talk about a particular algorithm for calculating the price, the cost, the total cost of a shopping basket. Now, let's say one day your client says, look, I would like to build this shopping cart. It's going to be very basic. All I want is these products to be sold on my website. And I just need you to create an algorithm that calculates the total of the basket. There's nothing fancy going on here. It's just these products have this cost. And so you go, okay, let's go ahead and build this algorithm. And what it does is it very simply just takes the sum of the products that have been added to the basket multiplied by their quantity. That's all it does. Okay, so you could get away with doing that in your controller because it is only very basic. But to be fair, this is an algorithm, so it shouldn't really go into the controller. It should be somewhere else. If you put it in your controller, in the future, you're going to find, that you're going to be moving this out. Because I've got various steps and future challenges on this. So what I would do is I would create a model that represents the contents of your cart. Maybe it's order items or cart items or whatever, and it's a collection of your order items, and you have a number, a counter of the quantity, and then you have the total cost. That is the calculation of all the products multiplied by their quantities. And that's it. And what I would do is I would have that in a service, and then have the controller call that service. Maybe if it's use some dependency injection, so you could either inject it into the controller action, or that becomes you import that in and harness that from your controller action, and then you just say, look, this is the request that was given. All of these products. Now go away and do that calculation, and then come back with a single figure that says the total cost. Okay, so that's pretty straightforward. That's pretty straightforward. Then what happens is that in a few months' time, your client says, we actually now want to provide our customers with other products, and those other products need to be we need to calculate VAT. We need to calculate tax on those products. So now you've got products that have VAT and those products that don't have VAT or tax, wherever you are. So the challenge there is that you need to discover where the customer lives or where it's going to be shipped from in order to work out the tax calculations, because tax can only go on to certain products and tax rules differ depending on where the customer is. There's different tax rules for different countries, for instance, and you could even break that up and say, well, there's different tax rules for different states in the US. So now you've got that question of, I now have to show two very separate costs, one which is excluding VAT and one that has VAT. So including and excluding VAT. And I can only calculate the VAT or the tax once I have established where this product is going to be shipped to. Where does this customer live? So now I have other things to throw into the algorithm, into the mix. First of all, I allow the customer to put in as many products as they want and adjust their quantities, and then that goes off and does the original algorithm, because at this stage I don't know where they live, so I don't know any VAT implications. And then when they get to the checkout, when they put in all of their address details, then I can recalculate all the things in their basket with the VAT. Now, I've also got to ensure that certain products are eligible for VAT, tax. I keep saying VAT, tax, and while certain others aren't. So there's that kind of complication as well. So you can see how this is slowly starting to build up. So maybe you have a function, and that function does the initial, basket total, X VAT. And then you have another function that takes that plus the details of where that customer lives and looks upon some sort of matrix that says, okay, yeah, this customer lives at this place, this is the postcode or the zip code, and therefore we have to, and this is the product SKU that we've got, and therefore we need to follow these VAT rules, which means that now we make another calculation based on this. Notice that all we're doing is we're changing the number. That's all it is. It's just a change of number. It's this algorithm just changes the total basket, the total cost of this basket. It's going through various different checks and changes. Okay, so we've done that. That was a bit of work, because doing all the matrix for all the places in all the world, it's a big job. So we've done that. Woo. Okay, the next one is that the client says, "Wow, okay, this was great, but now we want to provide discount codes." And a customer can put it in a discount code. They must put that discount code in after they've actually provided us with their shipping details. Okay, so that discount code is going to be on a database somewhere. There's going to be an expiry date on that discount code, or maybe there's a quantity on that discount code, or maybe that discount code has a particular type of value. So for instance, it could be a percentage discount, or it could be an actual, a figure off, if you will. And so what you do is you do that discount code, you do that discount after you do the VAT calculations, or it could be before it, you got to have that conversation. It could be one after or before, but it can't be done until they put in those shipping details. Okay, so you're now starting to create the precision of this algorithm. So first of all, the first step is to create the sum of the basket, X VAT. Okay, so I've put in 5 products at this amount of at this cost, and therefore my my basket total is 5 times whatever this is. Fine. Then I go and put in my shipping details, and then the algorithm that makes another calculation to work out, you know, the changes to that, and then the user provides a discount code, a promo code, and then the discount is applied to that. Again, all it's doing is just changing that number. It's just changing that number. The client goes, okay, that's cool, but now we have discount codes that are only related to various places in the world. Okay, so a US discount code or a UK discount code, and also discount codes can only, certain discount codes can only go on certain products, and certain discount codes can only go on products that have you've added certain quantities to. Excellent. So again, you put in some more checks after that, the VAT checks, and you know, the whole cycle goes on and on and on. And maybe they say, okay, well, maybe we've noticed that a lot of our customers, they purchase 2 of these things. We would like to incentivize them to purchase 3 of these things. So if they purchase 2 of these things, provide them with some sort of message that says if they purchased a 3rd one, they get that for half price. Okay, you see where this is going. So you end up creating more and more little pieces of functionality that changes the output of this final figure that is the total. And all it is just a figure. Now you want to put in a bunch of checks. You know, you want to make sure that things are valid. You want to make sure that the user lives in a place that exists. You want to make sure that you know, you have stock available for all of this. So there are various different things that you need to keep checking in order for this to actually work, to be feasible, right? To be feasible. But the output is always going to be the same. The way I look at it is like a series of cogs, right? You have a series of cogs, and all you're doing is you're adding another cog to the end, okay? So it's just spinning, and it's just spinning, and it's just spinning. But you want to make sure that there are steps that require the previous steps to be fulfilled in order for those other steps to actually be activated and to be worked upon. It might be that the user lives in a place that doesn't have any VAT, doesn't have any more than I don't know, 1 product, and therefore isn't eligible for any kind of discount and doesn't have a promo code. So it is just your so in that case, there is no point in going through the whole motions, because what you've received as a series of requests doesn't fulfill the requirements for those algorithms to be put in play. Again, this is the feasibility. There is no feasibility for this to happen. Okay, so let's try and rein it back into the original question here. Where should I put my algorithm? If we're talking about the algorithm that we've just described, I would put this in the model layer. I would put this in a service. I would import that service or class into your controller, and then I would feed that algorithm the requests, and then out pops the overall price. Hey, Daryl Evans, thank you for joining. Appreciate it. Thank you. So that's what I would do. I kind of want to talk about the strategy pattern. This is a design pattern that selects different algorithms to be used. I mentioned just a minute ago that in certain cases, those algorithms won't be required. So, for instance, a user may live in a place that is VAT exempt, or a user may not provide a discount code. A user may provide a basket that doesn't have a quantity that has any kind of level of discount or free shipping or whatever you've got associated to that quantity, that bonus quantity, that kind of thing. And so what you would do is you would devise a strategy that would fire off those steps that are required. And what I would do is I would create a class for each one of those algorithms. And now what I'm doing is I'm breaking that whole algorithm up into a series of steps, shall we say. It's a series of steps. I would create a class for each one of those steps. And I would use the strategy pattern to work out which step to run. So, for instance, if I don't have a discount code, don't run the discount code step. Okay. If I don't have the necessary quantity, don't run the quantity discount step. Don't do it. There's no point. You're wasting time. Don't bother with any of that. You shouldn't be sending algorithms data that it doesn't need. So I would be using a strategy, the strategy pattern for that. Now the strategy pattern uses composition instead of inheritance. It is operated by a series of interfaces, and then you would have a series of classes that implement those interfaces. And that's how it would all sort of hang together. So algorithms, in my opinion, they're business logic, and the business logic needs to be in the model. You shouldn't be doing this in the controller. You certainly shouldn't be doing this in the view. And yeah, that's my take. That's my take on algorithms and where they go. I believe the person who suggested this has a Python background and was talking about Django and Flask, which are great frameworks in Python. So with Flask, Flask is a very nice lightweight thing. I would create these as classes and then import those in. And what I would do is I would have an overarching class like calculate shipping total, calculate basket cost class, something like that. And that would then be able to interact with those other classes that implement those interfaces that are required to do those things. And maybe that interface would have, a method, get total or something like that, and calculate. That's another good one. So they would all implement that sort of level of what am I trying to say? They would implement those methods, and then you would have various other steps that would decide and call upon the database for things like getting your the VAT rules, or for getting your discount codes, because they're going to be stored somewhere. And then once the steps have been defined and have been laid out, you then run a process. And that process then runs through all of those classes, all of those steps, runs the calculate in the order in which they're required, and then returns back the overall get total. And that's how I would do it. I don't do this in a controller. I've seen so many places where these kind of calculations, they're kind of dotted around the application all over the place. I've even seen some in views. Don't do it in views either. That's a bad place. If you're putting an if statement in a view, then you've got to rethink your view, in my opinion. Or a switch statement. I've seen switch statements in views. Don't do that. Your views you should give your views the data after the data has been processed. The view shouldn't care about the data. It should just display it. It shouldn't make any decisions upon on that. Yes, there are certain things that a view should do. For instance, if a user is logged out, then show this menu. If a user is logged in, show that menu. Yeah, fine, I get that. But in terms of calculating a cost for a shopping cart, don't do it in a view. Do that in the model layer. That's what it's there for. Now there is let's dive into this a little bit more, because I'm just said let's do it in the model layer. Yeah, okay, fine. But let's talk about the model layer. So you could have a series of models that represent your tables in your database, right? So then the question is, which of those should I be putting this in? And that is a very subjective question, and it really depends on the context and the root context of your of the thing that you're trying to calculate. So for instance, it could be that you're doing this from the context of a user, or you could be doing it, in this example, doing it from the context of an order item. I mentioned before about maybe having a model that represents the basket. You could do that. You could put it in there. Your models don't have to be a one-to-one to the tables, not at all. So you could probably do it there, and then maybe in that model inject the other various relationships. That's probably a good win, but make it so it's flexible, so you can move it around. It's not coupled too tightly to a single thing. Otherwise, when it comes to altering that, again, you want to make sure that it's flexible enough that you can just sort of import it in various different places. You don't want it to be too tightly coupled to a root context that actually has no relevance to the actual algorithm. And that can happen over time if the application changes, your client's requirements change, as I've just mentioned, a load of client requirement change there. If those requirements change over time, but the actual code doesn't get altered and changed and cleaned up from an architectural point of view, it's still tied down, anchored down to a root context that actually isn't the root context anymore. I've seen applications like that where you have other root context being injected in and then worked upon that. That's not good. So you want to make sure that you can pick it up and put it in other places. So the way I work with that is I create a series of adapters to adapt into various entities, let's say, that adhere to a series of interfaces that I can then use as sort of a snap together type affair. But we're moving into various different places that are less algorithms and more architectural sort of decisions. But let's just say that you shouldn't just think that where you put your algorithm is where your algorithm is going to end up. Let's just say that. Okay, so I'll go through those snippets in sort of a quick run through. So MVC, what is MVC? So M is the model. It cares about the data. Its concern is the data integrity, validation, all of that jazz. The view cares about the representation of the data. It doesn't care about the actual data itself. It cares about the representation, how it looks. Remember, a view could be an API response as well. The controller is the router. It is the mapping between the request and the response. And the algorithm is a series of instructions that perform a specific task. Think of it like a recipe, as my bad example was. Think of it as you're creating some toast. You're not going to be buttering your bread and then putting the bread into a toaster. That doesn't work, believe you me. What you want to do is put the bread in the toaster, wait for the toaster to actually do its thing, that is its process, and then once the bread is toasted, you then butter it. You don't do it the other way around. Therefore, an algorithm, some of the characteristics of an algorithm is that it has an input and an output. It also has a level of precision, so steps can only be taken in a certain order. An algorithm must be feasible. So for a step to be performed, there must be some sort of thing for it to be acceptable. And then flexibility. Make sure that your algorithm is nice and flexible in terms of where it lives. The fact that you've split this up into little classes that represent each step in your algorithm, which means that you can use your SRP to really boil down what it is that step is doing. That step should only be concerned with that step. You shouldn't be concerned with the other steps, only concerned with the input of that step and the output coming out of that step. Okay, so then you've got your, then I went through the example of the shopping cart and the various different changes to that. And then I discussed the strategy pattern as a means of deciding which type of algorithm to use, or even which step to put in play. And as I mentioned, algorithms are business logic. Business logic goes in the model. Great. Well, thank you ever so much for watching. Happy coding. I am going to finish my beer. I haven't really drank a lot of it, to be fair. So nice. I don't want it to warm up. And I will be live again on Twitch on Sunday at 14:30 GMT. We are working through the How to Code Well site. And yeah, it's coming on quite well. It's coming on quite well. Hey, Mohammed. That's perfectly fine. I really appreciate your kind words. Thank you. Thank you. If you've got any other questions, please don't hesitate to let me know on Discord. And if you've got any suggestions, for the next week, or the future podcast, then do let me know. I also had a really good suggestion about tutorial hell, so I might be I might be talking about that next week. Yes, I would process all of those in the model. Yes, definitely. All those methods will be processed in the model. What I would do is I would have a series of classes that represent each one of those steps, and then I would have and then you would have in each of those steps you would have perhaps a method called calculate, right? So a very generic method just saying calculate. And then you would have maybe get total, another method, get total. So the body of the calculate method would be different for each one of those steps. This means that you can now use polymorphism as a means of going through and looping through a collection of steps that you can that you define in in an array or whatever. So you would loop through those, and you would call calculate on each one, passing in the get total as both the input and the output each time, and then you would finish returning the get total. And I would do that in another class. So you would have a class which has maybe a method called process, right? A process would take your input, and then it would have an array of of classes which are steps, and it would loop through those steps in the order that you define, and it would pass in the input into each one of those, and those would do a calculate. It would then do a get total, and that get total would become the input for the next step, and so on and so on and so on until they're all done. Yeah, think of it like a bunch of cogs just going through. And then, yeah, that's what I would do. So I wouldn't put any of this in the controller. Certainly wouldn't put any of this in the view either. I hope that helps. I hope that helps. Right. Thank you ever so much for watching. Happy coding, everyone. And I'll see you again soon. Cheers. Bye-bye.